Hey guys, welcome to our next lesson. Today's lesson is going to be about density curves. So we'll eventually see what density curves are all about, but let's build our way towards that by starting with this. So I've updated the quarterback data. So this is now after 3 weeks. This is the average number of fantasy points per week. We're down to 28 quarterbacks that have now played a full 3 weeks. So here are the 28 quarterbacks and how many fantasy points per week they're averaging after 3 weeks. So what I'm going to do is I'm going to take this stem plot, I'm going to convert it into a histogram over here. And the shape of that histogram should be pretty familiar based on what this stem plot looks like. So let's do it. So my first category is from 10 to 15, although it's really from 10 to 14 because this is going to be for us, we'll call this 10 to 15, not including 15. This will be 15 to 20, not including 20. So in other words, 15 to 19, 20 to 24, and so on. So how many quarterbacks do we have in this class from 10 to 14? We have 3. We have 2 quarterbacks with 12 and 1 quarterback with 14 per week. So there's 3 of those. So we have a frequency of 3 here for this first bar in our histogram right there. By the way, who are these really underperforming quarterbacks? Well, one of them plays for the Redskins. I think he's about to lose his job. Haskins, not doing very well. And the other 2 play for 2 teams that I think are pretty close to home for us. That would be the New York Jets quarterback and the New York Giants quarterback. Okay, so how many do we have here from 15 to 20? Well, 1, 2, 3, 4, 5. So we have 5 of those quarterbacks. So in this range from 15 to 19 fantasy points per week. So that's not too good. But notice we have a whole bunch of quarterbacks that are between 20 and 24 fantasy points per week. So these are your mediocre quarterbacks. I have one of those mediocre quarterbacks on my team, Tom Brady. But there's 12 of those, right? So from 20 to 24, we have 12 quarterbacks, right? So this is going to be a pretty high peak in our histogram at 12. All right, so we have 3 quarterbacks here, 5 here, but we have 12 here. All right, how many do we have from 25 to 30? Well, we have 3 quarterbacks there. And now we're starting to get to the quarterbacks that fantasy football players want to have on their team. So I wouldn't mind having one of those. Or this guy at 31. There's only one between 30 and 34. But there are 2 quarterbacks between 35 and 39. They happen to both be 35s, I guess. But 2 of those. And there are 2 quarterbacks between 40 and 45, I guess. So that would be the next bar right there. I mentioned that this shape would be familiar because basically this shape that you see here, if you just turn it 90 degrees counterclockwise, you get this shape right here for our histogram. All right, so this is just a frequency histogram for the fantasy points per game. What quarterbacks do you want on your team? You want one of these guys. By the way, these 2 quarterbacks are Josh Allen, the one I passed on to pick Tom Brady, and Russell Wilson, right? Okay, so anyway, that's our frequency histogram, as we call it. I should label this, though, as fantasy points per week. So QB fantasy points per week. And those are the frequencies. And if I fill in the other numbers, so there were 3 of these, 1 of these, 2 of these. So it should add up to 2, 4, 5, 8, 25, 28 quarterbacks. Oh, by the way, we know this, that we can estimate a median, right? We have 28 quarterbacks. There's no quarterback in the middle, so it would be the average of the 14th and 15th. Well, I haven't reached the 14th or 15th yet. I still haven't reached the 14th or 15th yet. I have 8 quarterbacks so far. But definitely, both the 14th and 15th are in this class right here from 20 to 24. So all I can say is, if this was all I had, that the median is somewhere between 20 and 24, right? With the stem plot, however, you can get the exact median because you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's the first 14, and then the next 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the median would be the average of 22 and 22. So the median is 22. There's Tom Brady right there. Boring, mediocre quarterback, 22 fantasy points per week. We'd rather have one of these guys. But anyway, were we right? Was it somewhere between 20 and 24? It was. But if you only had the histogram, you wouldn't know that it was 22. It could have been 20, could have been 21, could have been 22, could have been 23. Turns out 22. And of course, we can get the exact Q1 here. We can estimate Q1. We can estimate Q3 there. But really, what I really want to do with this, sorry, I'm trying to get the words out. It's kind of late at night. Okay, what I really want to do is I want to get what's known as a relative frequency histogram. So in order to get to this, the relative frequency histogram, I have to get relative frequencies. So these are the numbers in each class, 3, 5, 12, 3, 1, 2, 2, right? But this is frequency. How would I get relative frequency? Well, pretty simple actually. So the next column, I'm going to call it relative frequency. Remember, there are 28 total quarterbacks, right? So if I do 3 out of 28, that's going to give me the relative frequency, right? So 3 out of 28 turns out to be about 11%. So I'll call that 0.11. So 11% of the quarterbacks are between 10 and 14 fantasy points per week, including those two from the Giants and Jets. And now we have 5 out of 28. If you did 5 out of 28, that's approximately 18%. So that would be a relative frequency of 0.18 or 18%. So 18% of all the quarterbacks are between 15 and 19 points. But there's a whole bunch between 20 and 24. So that's 12 out of 28. 12 out of 28 is about 43%. So 43% of the quarterbacks are somewhere between 20 and 24 fantasy points per week. Next up, we have another 3 out of 28. So that's going to be 11% again. 1 out of 28 is approximately 3%-ish. So we'll call that 0.03. And 2 out of 28, what's that? That's about 7%. So 7% of the quarterbacks here, 7% of the quarterbacks here. Okay, so now let's build the relative frequency histogram. And this too should look familiar. So let's take a look. So when you see its shape, again, it should be very familiar. So what percentage do we have scoring between 10 and 14 points? We have 11%. Now, I do want to label this. My biggest relative frequency is 43%. So I got to make sure I get up to at least 43%. So let's see, if I go 5, 10, 15, 20, 25, 30, 35, 40, 45, that should do it. So let's call this 5%, 10%, 15%, 20%, 25%, 30%, 35%, 40%, and 45%. Okay, so back to this class, 10 to 14, 11%. So 11%, the bar would go up to 11%. That's somewhere over here. So 11% of the quarterbacks, averaging between 10 and 14 fantasy points per week. Between 15 and 19, we have 18%. So 18% will be somewhere around here-ish, right? So there's 18%. So this was 11%, 0.11. This was 18%, 0.18. But we have a big percentage, 43%. So 43% of these quarterbacks, almost half, between 20 and 24 fantasy points per week, 43%. Okay, 25 to 29, we have 11%. So another 11% bar right here. Excuse me. And then 30 to 34, we have 3%. So that's going to be a small little bar here, 3%. 0.03. But we have 7% here and also 7% here. So 7% would be somewhere around here-ish, I guess. So 7% and 7%. I mentioned that should look familiar. Let's see if this looks familiar. It looks exactly like this, right? But what makes it a relative frequency histogram is that we're talking about percentages here. What percent of the quarterbacks are here, right? What percent of the quarterbacks are here? So it's a relative frequency histogram, has exactly the same shape as the frequency histogram. But we introduced the idea of the relative frequency histogram because I want you to realize something. What would you get if you added up all of these percentages? And hopefully you know what you would get. You would get 100% or 1, right? So let's do it. 0.14, 0.17, 0.28. 0.28 plus this one is 0.71. 0.71 plus this is 0.89, and 0.89 plus this is 100% or 1, right? So the total of these numbers is going to be 1. Keep that in the back of your minds. Another thing I want to show you, we know the median is between 20 and 24. Actually, we know it's 22, but let's forget we know it's 22. You can use a relative frequency histogram, of course, to estimate the median because we haven't reached 50% yet. We're at 29%, but we're definitely going to reach 50% by the time we get to this bar, right? So the median is definitely between 20 and 24. Again, using those relative frequencies or percents. You're looking for that 50th percentile or 50%. Definitely in here, right? 29 so far, so 50 is going to be in there. Okay, now we said that if you added these all up, you would get 1. Because now we're ready to introduce this idea of a density curve. And here is what a density curve does for us. A density curve is a curve that tries to capture a relative frequency histogram. So if I had a curve that did something like this, right? Some kind of a curve, right? So this is looking like a right skew distribution, right? And this curve is a model for this distribution. So if I draw that picture, and I guess I'll draw it smaller over here. The picture looks something like this, so it's definitely right skewed like this. I won't do the, down and then back up again. I'll just go like this. So this is a model for this relative frequency histogram. We like to use curves, in this case this right skewed curve for these quarterback fantasy points, and we like to estimate areas under that density curve to guess certain values. So let's say, I don't know, let's say 30 was over here-ish, and 40 was over here-ish in my density curve. If I find the area under the curve between 30 and 40, and this is a good model for the relative frequency histogram, well, you notice in the actual relative frequency histogram, we have 10% of the quarterbacks between 30 and, let's call it 39 fantasy points. So if you find this area right here, this area, if this is a good model, should be about 10%. Now, of course, we're using a model for the data, so it's probably not going to be exactly 10%, but the better the model is, the closer it'll be to the actual 10% that we have between 30 and 40 or 30 and 39. So that's the idea of a density curve, right? It models the relative frequency histogram. Similarly, if I went between, 10 and 20, let's say 20 was here, and 10 was here. If this was a good model, this area would be somewhere in the neighborhood of 29%. Probably not exactly 29%, because again, we're talking about a model here, right? And this is how density curves work. But one thing before we define this formally is if I got the area under the entire curve, what should that area be equal to? It should be equal to 1, right? Because 100% of my quarterbacks should be captured by this density curve. And you can see why that sum is 1, because you can see the numbers in the relative frequency histogram. Okay, let's define a density curve more formally next. Okay, we're ready to more formally, I guess, define a density curve at this point. But keep in mind that it is a model for a relative frequency histogram. That's what a density curve is. And the two requirements of a density curve is 1, it lies at or above the horizontal axis, the x-axis, which makes sense. If you picture a relative frequency histogram, it's never going to dip below the x-axis, right? So that's one requirement. But the other one, the more important one, I think, is that the total area below the curve is always going to be 1 because it captures 100% of your data. In our example, 100% of the quarterbacks, right? So, a couple of things to keep in mind about how the median and mean relate to a density curve. Now, first of all, if you want to find the median of a density curve or eyeball where it is, it's going to be what we call the equal areas point. So the median is going to be the equal areas point. And this is going to be easier for us to eyeball, I think, than the mean will be. So we'll talk about the mean next. But the median is going to be the equal areas point. So if you think the mean is here, I don't think that's the case, because I think you can see we have much more area to the right than we do to the left. So where the median is has to be a little bit to the right of that, I think. And maybe, I don't know, just making a guess, maybe this area has a shot at being equal to this. So assuming that, of course, we have 50% of the area here, 0.50 here, and 0.50 there, if this area is the same as this area, then I have found the median, okay? So it's a little bit easier, more easy to eyeball, that is, than the mean, because the mean's a little trickier. We'll see how this works in a second. Because the mean, unlike the median, is what we refer to as the balance point. So the mean is the balance point. And this is the one that's a little bit more tricky to visualize. But what you have to think about is that this density curve is like three-dimensional, and we're trying to balance it, right? Now, if I put that balancing point here, right, what would happen to this, because of its shape like this, again, picture this as being three-dimensional, it would probably tip over like this. And that's what this picture is supposed to indicate, right? So if I put the balance point where the median is for a right-skewed distribution like this, it's going to tip over to the right. So where would the balance point be? Of course, it's tricky, right? So I don't know, maybe here, right? So maybe that would be the balance point that would have this long tail balance with this other side on the left, right? Again, very hard to see with a mean where exactly that would be. But hopefully you realize that if you put it here, this thing's going to tip over like this. So you want to place the mean in a place where it wouldn't tip over, it would actually balance. So assuming that's the balance point, the mean might be here. So this could be your mean. And as we already know, if your distribution is right skewed, and I've drawn all of these density curves right skewed, kind of like our quarterback relative frequency histogram was right skewed, we know that if it's right skewed, the mean will be pulled in the direction of that skew, right? So if the median is here, if I try to apply that to the curve that I've drawn here, so the median I had was like, I don't know, maybe here-ish or something. So the median, if it was here, because of this right skew, the mean would be pulled to the right of that median, because the skew doesn't really affect the median, but it does affect the mean, right? So again, the median is like the equal areas point. So I try to put that in the same spot here. The mean is the equal balance point, if you will. And again, if you're right skewed, the mean will be to the right of the median. And of course, if you're left skewed, the mean will be to the left of the median. And if you're symmetric, the mean will be the same as the median.